Mathletes, we're going to do a 2-for-1 special today. We're going to do 6.2, 6.3. We're going to do inverse and radical functions all in one video. And radical functions are a type of inverse function. So we'll learn about inverse functions, and we'll talk about a specific inverse function, which is a radical function. All right, so first of all, an inverse relation, what that is it's a set of ordered pairs where you reverse the coordinates. Okay, so you reverse the coordinates. So in other words, you switch the x and the y. Okay, so that's what an inverse relation or inverse function is you swap x and y. Or in other words, you swap your inputs and outputs, right? You swap your domain and range. So that's basically what happens. Your range becomes your domain, and your domain becomes your range. So here you see an inverse function, and this is using function notation here. But so this is how you represent f inverse. So f to the -1. So that's not 1 over f, right? So that's not how we want to think of it. It's not like, you drop it like we've talked about before. So this just means the inverse of f of x. Okay. All right. Now, if we use this notation, we can say, okay, well, if f of a equals b, if that was true, in other words, if our input is a and that yields an output of b, then the inverse function, if you plug in b, then you get a. All right, so once again, it swaps the input and the output, right? So your output becomes your input, and your input becomes your output. All right, and we'll come back to this slide later, and we'll do a little more investigation. But let's just see, with sets of ordered pairs, you'll see pretty much how straightforward it is in terms of inverse, right? So if it says find the inverse of each relation, all we're doing is swapping inputs and outputs, right? So if this was my original function, 0, 9, 0, -9, 5, -3, 6, 6, and 8, -3, then the inverse would just be the same. You'd have the same number of coordinates, but you would just swap, right? Swap the x and the y. So now that point, instead of 0, -9, becomes -9, 0, right? X becomes the y, y becomes the x. This one would be -3, 5, right? This one would stay the same, right? Because x and y were actually the same, so we still swap them, but it doesn't look any different. And then 8, -3, -3, 8, and that's it. Okay, so all we have to do is swap the x's and the y's. All right, so I'll let you do this one. All right, did you get it? This is what the answer should be. And yeah, so we just swap the x's and the y's, right? Pretty straightforward. And notice how here we had a y-intercept, right? And now that becomes an x-intercept. So y-intercepts become x-intercepts, right? So we're just flip-flopping the inputs and outputs, right? So everything that was on your y-axis before is now going to be on your x-axis. Everything that was on your x-axis before is now going to be crossing through your y-axis when you get an inverse.